is the last lesson of the chapter, and we're going to be talking about how to solve any type of equation. It doesn't matter if it's in logarithmic form, exponential form, but pretty much there's three basic rules. And the third rule is actually just a shortcut of one of the other rules, but sometimes on the ACT they'll ask you about that one, so I'm going to talk about it. And in order to be successful at this lesson, I want you to have 3 note cards out, and we're going to write the rules on the note cards. Okay, so we're going to talk about the first note card here, which we call loop-de-loop. Now you need to know when to do loop-de-loop. Well, the when is the same thing we've been talking about all chapter. So if you're trying to get rid of the word ln or the word log, so it doesn't matter if it's an ln or a log, we are going to rewrite into exponential. And the only way to do that is to loop-de-loop. So if I look at this, you have to remember that this base is e. So we're going to start with the base e. Remember, we're going to get rid of the word. We start with the base, we loop over. I probably should change this problem. Let's change the problem to just plain 5 because 50 is going to be way too big. So it's going to be e raised to the 5, and then you come back. So then to get the answer to your variable x, you actually are going to type in e to the 5 into your calculator. And with these problems, we always run a round out to 3 decimal places. Now again, we can check our answer. If we go ln of 148.413, it should be really close to 5. It won't be exact because we rounded this. Okay, same idea because we have the word log in here. We want to get rid of the word log by doing loop-de-loop. Loop over and come back. And so 3 to the 4th is going to be 81. Okay, so let's check it. Log base 3 of 81, will that give me 4? Well, the last lesson you learned how to type these in a calculator just the way they are by rewriting them as the change of base formula. So the base 3 goes on the bottom. So if you type that in, will you get 4? Yes. So we're going to make these note cards in class. Note card 1 is called loop-de-loop, and we're going to put one of these examples on it. Okay, this is called note card 2. So what's going to happen is if there are no words whatsoever in the problem. So you can definitely see there's no words here. But what you got to do here first is you need to simplify and get 4 to the x alone. So keep that there. Add 3. Now by this time, a lot of you are probably so used to doing this that you know what to do. If I rewrite this in the log form, the base is 4, the exponent I don't know, and 13 goes here. You can go ahead and type this right in your calculator. So we would go log 13 divided by log 4. But what this note card is saying to do is when you get down to this point, just put the word ln in front of both sides. Now the reason I'm going to have you insert the word ln is because sometimes you have to do ln, sometimes you could do log, but you can't do log all the time. So instead of having for you to figure out, okay, wait, should I do ln or should I do log, or doesn't matter, let's just stick to ln all the time because then you know it will always work. And then our exponent gets brought out in front. And then if I want to get x alone, to get rid of multiplying by something, we divide by that number. Now if I type in ln 13 divided by ln 4, or I type in log 13 divided by log 4, it doesn't matter, it's going to give me the same answer. And that's because with this problem, it wouldn't have made a difference. Alright, so this one again, there's no words in the problem, so I'm going to insert ln in front of both sides right now. And then because I have exponents, I'm going to bring them out in front. That was a rule from the last lesson. See, I'm going to write it. I'm going to write 2x minus 1 in parentheses times ln 25 equals 4x in parentheses times ln 625. And the reason why we're putting these in parentheses is we want to keep that exponent all together. Now, do you want to get rid of the ln 25 or do you want to get rid of the ln 625? It's not going to make a difference. I recommend you always get rid of the smaller one so you don't have to worry about any fractions. So ln 25 divided by ln 25, all of that will cancel. Now I can drop the parentheses because there's nothing around the parentheses. However, if I do ln 625 divided by ln 25, I'll get 2. 2 times 4x will give me 8x. And now I just go into solving like a normal problem. Divide by 6, divide by 6. Here we go. Ladies and gentlemen, that's pretty much the lesson. Okay, but what I'm going to do now is I'm going to give you some more complex problems, and then you've got to figure out which note card to use and then apply it correctly. So let's take a look at this problem right here. This is saying 2 minus 3 times ln x equals negative 4. Well, I do see that there's one ln in the problem, so I'm going to loop-de-loop. But you can't do that yet until this is all by itself. So slowly but surely you're going to get rid of things that are in your way. So now I've got negative 3 times ln x is equal to negative 6. I'm going to divide by negative 3. ln x is equal to 2. Once you get that ln x by itself, now we're going to do loop-de-loop, but you got to remember that there's that little e there. So it's e raised to the second power will give me x. So go ahead and type that in and then round your answer to 3 decimal places. So we'll get 7.389. But I need you to recognize we couldn't really start to do the loop-de-loop until we got all the way down to here first. So if you look at this problem, if you notice that this is just e to the x, there are no words whatsoever. If you think there are words, come talk to me, because there are not any here. So we need to get the e to the x alone. So we're going to minus 4 minus 4. We divide by negative 2, divide by negative 2. And then because there are no words, we're going to insert ln on both sides. Bring the exponent out in front. And then we're going to divide by ln e. So go ahead and type this in, and you'll get 2.603. On this problem right here, you notice that there is one word in the problem. Because there's one word, we're going to do loop-de-loop, but we can't do that yet until we get ln x alone. We need to get ln x be the only thing there. So we're going to divide by 12, divide by 12. I've mentioned over and over again, leave this as a fraction. You don't even need to reduce it because we're going to type in the calculator anyways. And there's an invisible e there, so we're going to go e raised up to this and come back to here. So go ahead and type it in. Alright, so there's one word in the problem. So therefore we're going to, again, do loop-de-loop. And this time, if you notice, this is already all by itself. We don't have to get rid of anything in front, and we don't have to get rid of anything behind. So we're going to go straight into it. 6 raised to the third power equals this, which is 216 is equal to 4x plus 9. Subtract 9. 207 is equal to 4x. Divide by 4. This time we're not going to go out to 3 decimal points, and that's just because the decimal we end up getting doesn't go out that far. Alright, so here there are no words in the problem, so we are going to insert ln, but we have to get the e to the 3x alone. So we're going to subtract 2. Once you get down to the e to the 3x alone, that's where we put the ln in front of both sides. And the exponent gets brought out in front. So 3x, keep it together, times ln e should equal ln 3. We get rid of multiplying by dividing. So we have 3x equals. Go ahead and type this whole thing in right now. We're not going to round because we're in the middle of the problem right now. And now that's what's equal to 3x, so now we divide by 3. And at the end of the problem, we can go ahead and do our rounding. So that's the basic idea. Know which note card to use, which means which method to use. You may have to simplify first.